Yeah, you don't like printed stuff, so.
Well, I didn't grab the test. Let's grab
Oh,
this
okay.
one.
All right, everybody. So let's make a plan about what we're going to do today. So, firstly, we can hand these back. All right, so I've got them ready to pass back to you now that they're all done. But I'm thinking, let's just dedicate this time to begin with to our stats stuff. And if I find we've got some free time towards the end of the lesson, that's when I'll hand them out, because I do want to talk about a few things for the class with it. But I think right now it's sort of a bad time to hand them back because we're focused on this. So it's scheduled for this Friday. Okay, if that's an issue, I'm very happy to arrange an alternative time for you to do it, given the constraints that are taking place this term. So I'm very happy, but this Friday. Now, we've got a few things I want to talk about with you guys, and then the remainder of the lesson will be individual study. So the first thing that's popping up for us is this table tennis question. So this is from the textbook, and if you've had a look at the practice test, this question has been asked a fair bit in the practice test. It's no guarantee that it's going to pop up, but I'll just talk about how you evaluate a question like this. It does require a little bit of inside information about tennis. In the test, there's no assumptions made about what you know about tennis or stuff historically. All right, so that would be the same if it were to pop up in this year's test, which it may or may not. Okay, Martina beats Jelena in 2 out of 3 games of tennis. All right, so that means the probability of Martina winning is 2 out of 3. What is the probability that Jelena wins a set of tennis 6 games to 4? Okay, so straight away they've asked about the inverse event. So the probability of Jelena winning is 1 out of 3. That's the probability that she's going to win any game. Now, a game of tennis finishes when the first person reaches, Will?
4 points. Game
6, is it?
Yeah.
6. You're the tennis player, right? Okay, so it says they've won the games 6 to 4. All right, so I think it's first person to 6. Is that right?
Yeah.
That's what it says up here. Okay. So first person to 6 points wins. All right. Now what that means, okay, for her to win after 10 games is that the 10th game corresponds with her 6th win. Okay? She can't have won 6 games after 9 rounds, because then she's already won. All right? For it to occur on the 10th round, that must correspond with her 6th win. So the hint that they give us is, what does the score after 9 games need to be? So after 9 games, she has to have 5 wins. So the first thing we're going to do is calculate, what's the probability of her winning 5 games out of 9 in any order? So this is an exact event, 5 games out of 9, okay, in any order, and the probability of her winning a game is 1/3. So what we have there is the probability of her winning 5 games in any order. So like, it could be that she won the first 5 and then lost the next 4, all right? And you can think of all of the possible arrangements of this. Have Jelena winning 5 games, all right? But then she needs to win the next game. So we're going to evaluate this and then multiply it by, what's the probability of her winning any game? 1 out of 3. So the probability of her winning 5 out of 9 games, and then multiply it by the probability of her winning the 10th game. Okay, so it's an exact outcome that's conditional on prior events. It can be a little bit tricky, but this is a question that does pop up in the practice test, and it is there in the textbook. Any questions about that in particular? All right, so people have got stuck on that before during the textbook work, so I just thought I'd explain that one. Now, if that's something you do want to practice, in the extra resources folder, and I can project it up here a bit later, in the extra resources folder, there's a document called Table Tennis Questions. And there's like 4 of them in there that are the exact same thing, okay, with some answers. So you can have a bit of a go at those questions if that's a skill you can practice. Okay, jump back to this one. So we talked about the table tennis question. All right, next we've got determine if a distribution is valid. So there will be a question like this in the test that wants you to determine whether a distribution is valid or not. And for a distribution to be valid, it must have all probabilities lie between 0 and 1. And so that means you can't have negative probabilities and you can't have probabilities larger than 1. It also means that all probabilities add to 1. Okay, so if you're asked a question that says show or determine if a distribution is valid, you need to demonstrate both of these. You need to demonstrate first that all the probabilities together will add to 1, and you also need to demonstrate that all of the probabilities are positive and lie between 0 and 1. So you need to demonstrate that both are true. Okay, that's that one. Now this is going to pop up in our question up here, so we'll go through this one together. Maybe I'll just address this first and then I can rub it out. So Bernoulli variable again, so that has two properties as well. The first is that there is one trial of the experiment. Okay, so it says one trial. And the second property is that there's only two outcomes, and we denote a success with x equals 1 and a failure with x equals 0. So Bernoulli variable, but again that's something that we've hit in the practice tests a fair bit. Alright, let's go through this question up here, and then that'll be everything that I wanted to address with you guys together. So we have the ratio with which John goes to sleep early or stays up late is 4 to 3. Okay, so what this means is that he goes to sleep early 4 out of 7 nights a week. That's the probability of him going to sleep early. Alright, and that he stays up late, alright, 3 out of 7. Okay, so 4 to 3 out of 7 nights in total, 4 of them are early, 3 of them are late. Very good. Determine the probability that John will go to sleep early on any 5 nights of the week. Alright, so this is the probability that he goes to sleep early 5 times during the week. So this is a BPD calculation. We're talking about 5 successes out of 7 trials. There are 7 nights in a week, and the probability that he will go to sleep early on any given night is 4 out of 7. Okay, so we'll evaluate that quickly. We've got 5, 7, and 4 and 7. Okay, this gives us 0.2350. So always write 4 figures and then round. Alright, so that's part A. Part B. John will play an elite game of chess if he goes to sleep, if he has at least 5 nights of sleep, early nights throughout the week. I've just written this question just then, so 5 nights of early sleep throughout the week. Determine the probability of John playing an elite game of chess. Okay, elite if at least 5. So now we're talking about the probability of being 5 or larger. So if you think of those events, 3, 4, 5, 6, 7, we're saying at least 5. So that means 5 or more nights of the week. So part B is a BCD calculation. We're talking about between 5 and 7 nights of early sleep out of 7, and the probability that he'll have an early night sleep on any given night, 4 out of 7. So that's our next calculation, 4, 7, 7, 4 on 7. Sorry, 5, not 4. 5, 7, 7, 4 on 7. 0.3593, 0.359. Okay. C. John's friend Pete claimed that the probability of John having n elite games in a row was less than 0.01. Determine the value of n such that John's claim is true. Okay, this is the probability of him playing an elite game of chess on any given weekend. Now, if we have n in a row, all right, if we're going to have 2 in a row, what it would mean is 0.359 squared. If we're going to have 3 in a row, it's going to be 0.359 to the power of 3. So probably the best way to evaluate this would just be, there's a couple of ways, but probably the best way will just be using trial and error. So I'm just going to go 0.359 to the power of 3, and I've got 0.0462. So what this means is the probability of him playing 3 elite games of chess in a row is 0.0462. Now, John's claim is that it's less than 0.01. So we're going to keep going until this gets smaller than 0.01. When I put it to the power of 4, all right, we've got 0.0166. So already I'm very close. And then we'll go to the power of 5. Change that. And we've got 0.0059. Okay? So what's the value of n that makes it true? 5 games in a row. Alright, the value of n has to be 5. Now, another way that we could do this is in equation solver. So you go to equation solver, type in equation, and the equation we would type in is 0.359 to the power of x, and we want to know when it equals 0.01. Now, if we solve this, all right, if we type this into equation solver and we press solve for x, you're going to get 4 point something, 4.3 something or other. Anyway, we're asked how many games. Now, if we have 4 games, we can see it's not true. It's not less than 0.01. So that means we need to round that up to 5 games because we're talking about discrete variables. Okay, so that's the answer to part C. Now notice how there was a link between part B and C, that we had to use this probability. This is the probability of him playing an elite game of chess, and then we've got n elite games of chess in a row. Okay, on to part D. Second part of C. Given John plays 15 games of chess throughout the season, what is the probability that 75% of his games, that at least 75% of his games are elite games? Okay, so 15 games throughout the season, we want 75% of them to be elite games of chess. So, if you think how many elite games of chess he's got, I'm just going to go from here onwards, 10, 11, 12, 13, 14, 15. Now the first thing we're going to do is calculate what's 75% of 15. Alright, so we'll just go 0.75 times 15, and we get 11.25, I think. 0.75 times 15, 11.25. So that's occurring here, 11.25. Now the question is, at least 75%. So if we included 11, that would be below 75%. All right, so that means we're saying 12 games or more. All right, 11 out of 15 is going to be like 73%. That is not at least 75%. So you must satisfy the criteria. So we're saying more than 75%, well that's 12 games or more. So then what we're saying is, what's the probability of him winning at least 12 games, or having an elite game, 12 elite games out of 15 possible games, 15 trials, and the probability of him playing any given elite game is this one we evaluated before, 0.359. Alright, so I'll evaluate that quickly. BCD, we've got 12, 15, 15, 0.359. And it's very low, 0.0006260. So it's 3 6 digs. Alright. So, any questions about that one that we've gone through? Okay, that's intentionally difficult. What I've done there is included, I think, 2 challenging parts, like part A and B, yep, should be able to do. But part C and part D, I'm drawing in a few of the challenging parts to show you how the questions can be a bit more refined, a bit more tricky. Okay, any questions people want to ask publicly? All right, so the way we're